Solving algebraically, we've shown you two ways to do this. So we can keep track of the inequality sign, or we can just find the boundaries, or where it's equal to 0, and test the number line regions on the boundaries. So we should really stick with testing, unless you're really good with the sign analysis or the keeping track of the inequality sign. You know, if you want to challenge yourself, you can do that. However, we'll do these ones by testing. So first of all, we want to find the boundary, which is a 0. So we need to make it equal to 0, and then we need to factor to find the 0. So I'm going to do x minus 5, x plus 2, okay, and I get my boundaries as equal to 5 and negative 2. So I'm going to just put that on my number line, negative 2, positive 5, okay, and we're not going to include the boundary, so I'm going to include that as open circle. Now, if you can visualize what the graph looks like, okay, it should be a graph that is parabola opening up, and you can then determine that above is going to be on the outside. We can also test. Okay, so we can test, and testing is very, if it's easy, it's a very useful strategy. So I'm going to test x equals 0. Okay, so when I plug in 0, I'm going to end up with, I'm just going to plug it in up here, 0 minus 10 is greater than 0. Okay, that does not represent a solution. This is not true. Okay, so then I could also test on here, but if I'm confident of that it will switch to a non-solution to a solution across that boundary, then we can draw in our solution like that. And again, with if I have a visual aid, which in visual aid is always going to be very useful, the visual aid will then confirm, because yeah, my parabola is above 0 in that region. I'm just going to still go ahead and test, because I'm not quite sure of this. So I'm going to test those two numbers. So I'm going to test it in the brackets. So I'm going to end up with 6. I'm going to test x equals 1 here. Sorry, x equals 6. So I'm going to end up with 1 times 8 is bigger than 0. 8 is greater than 0. Check. That is a good solution. I'm going to test negative 3. So I get negative 8 times negative 1 bigger than 0. 8 is greater than 0. Check. Again, that's a perfectly good solution. So that justifies my number line solution here. So again, we want to factor. We want to make equal to 0 first, because we want to know the boundary. Okay, so the boundary is important. I need to be able to factor this. So I'm just going to use my factoring here. Actually, you could use a quadratic formula if you like, but you want the exact values for this, because it is factorable. So negative 24x squared. So I'm looking for two numbers that multiply to 24 and have a difference of 3. So 24 and 6, well, this is not factorable, is it? So this is not factorable. So we have to use quadratic formula here. So we're going to end up with x equals 2, 3 plus minus square root 9 minus 4 times a times negative 12. Okay, so all over 2 times 2. So 3 plus minus, in this case, is going to be 96, it looks like. Square root 9 plus 96, all over 4. So we end up with 3 plus minus square root 105. So we need to establish that solution first, okay, and then putting it on the number line. This is going to be 3 minus square root 105 divided by 4. And then we have 3 plus square root 105 divided by 4. Those are our boundaries. It's equal to 0, so we want to include those boundaries in here. Okay, and again, I want to test a number. Now, to test these numbers, you do really have to have a sense of how big they are. So this is going to be about 3 minus 10, or about 7 divided by negative 7 divided by 4. So that's a negative number here. Okay, so it's about negative 1.7, somewhere around there. This is gonna, maybe I just write that down as a reference, approximately 1.6. And this is just a mental estimate. I have no idea what the actual calculation is. So here we have about approximately 13 over 4. So I'm going to say that's about 3.25 approximate. Okay, so we know that if I want to test the number, a nice number to test would be 0. Okay, so that's going to be my test number. So I'm going to test 0, x equals 0, okay, and plugging that into my inequality, I'm going to end up with 0 minus 12 less than or equal to 0. Check, that is a perfectly good solution. Okay, so my boundary region is going to be, my solution region is going to be here. Now, if I think of what this graph is going to look like, okay, it is a parabola facing up. I've got my zeros. So then my solution region should be below the x-axis, less than 0. That less than indicates that it's below. Yeah, this is a region that is below, so that's where my solution set is going to be found, in between the two zeros.